How is the traffic getting here? I've been in Bangalore about 9 days now, so I understand the traffic very well in this great city of yours. So let's get started. I was graciously introduced, so we can skip my bio. And let's take a look at business intelligence today. I feel that every decade has a wave, or every decade, or every 10 years or so in the IT industry, there is a dominating theme. Who can say what the dominating theme of the last 10 years was? Web, exactly, right? The last 10 years, we concerned ourselves with mostly the internet. And we went from 10 years ago with the dot-com era to just being happy to maybe push some of our applications towards the web, to today, pretty much all of our application development is some kind of web component, including web services and everything else. 20 years ago, when I started programming, it was just a big effort to do data entry systems. So 20 years ago, we did a lot of data entry. That's what IT systems were all about. And we were lucky if we just had a data entry system functioning properly. Then we moved to the web about 10 years ago, and now data is born digitally. How many people have applications where data is just, already digitized, already in your system? No one? One person? Okay, let's take a break here. Everyone raise your hand. See, you all have the ability to raise your hand. I'm going to ask the question one more time. How many people have an application where the data is born digitally? Ah, there we go. More than 50% of the room, about 60 people or so. Okay, so because we have moved past the point of data entry, and now applications have data born digitally, my feeling, and a lot of people's feelings, is that the next 10 years will be about doing things with that data, providing analysis, and that's business intelligence. A lot of .NET developers today, in my opinion, are a little fearful of business intelligence. They think it's very hard. And I make the argument that it's not, that it's actually quite simple. It's actually quite easy to do. So what I want to talk about today is one component of business intelligence, and that component is data warehousing. It's the first step. Let me ask everyone a question, since I know you all can raise your hand now. How many people in the room have the, have a database in front of them and they want to do some kind of business intelligence? Oh, wow, more than I expected. Usually a lot of people, how many people are currently working on a business intelligence project? Excellent. Oh, more than I thought. Usually when I give this talk in other countries, the hands don't go up as much, even after I've asked them, to raise their hands and say, who's here in India right now? And questions like that are easy to raise your hand. So that's good that most people here are already starting with business intelligence. I was going to say that if you're not currently implementing a BI or business intelligence project in your organization, what we're going to talk about today is still very relevant, because I'm going to assume that each and every one of you is going to build some kind of application that's going to present a report or report data down to the users. So this morning we're going to look at a design pattern that will facilitate two things. The first, it will facilitate good reporting to the end users, and the second, this data warehouse that we're going to build is going to facilitate the process of building true business intelligence solutions. We're not going to talk about building cubes today. Okay, that's for a different talk, different time. We're going to talk about getting to the point where you can build a cube, the very first step. So we're going to look at the process of, as I said, of building a data warehouse. So on my slides up on the screen here, I have some kind of just simple definitions, what business intelligence is. And in my opinion, it's any system that displays data in some kind of aggregated or summarized format that business users will look at and make decisions. So a report, a simple crosstab report or simple chart on a report, to me, is still business intelligence. And that is the beginnings of a proper business intelligence system itself. So BI allows the business users to make business decisions. And as I said, over the next 10 years, in my opinion, it's going to be one of the major trends in our industry. I think the other trend that we're going to see, which has nothing to do with what I'm talking about today, is parallel computing, right? Multi-core, dealing with parallelism. So there's Steve looking in the crystal ball that over the next 5 to 10 years, everyone in this room, myself included, will be concerned about business intelligence and parallel programming, on top of course, everything else. Because today we now take the web for granted and everything else like that. So, when we talk about business intelligence, what is the technology that's involved? And there's a broad set of technologies. For end users, there is reporting. There's pivot tables and things like Microsoft Excel. There's OLAP and data visualization, so actually going and connecting to a cube and using a cube browser to actually drill into the cube and look at KPIs, key performance indicators, look at dashboards and things like that. There's also data mining, and then there's also predictive analytics. So what does this mean for the developer? So what are the technologies that a developer are going to use? Well, one is data warehousing, and that's what we're going to focus on for the next 40 minutes or so. The other one is something called ETL, for extraction, transformation, and load. My opinion is the heart of the matter, and that's what we're going to take a look at today. So we're going to look at, it's going to be mostly SQL code, but then you'll see how you can integrate it into your .NET applications as well. But if you get this piece right, business intelligence is simple. I'll put it another way. Very few people get this piece right at all, and it actually becomes a bottleneck at their organization. And I get a lot of phone calls from CTOs and PMs looking for developers that can actually build, data warehouses. And I tell you, it's a great job market. It's something great that you could put on your CV. So over the next 40 minutes, believe it or not, you will see some techniques that you could probably go home and put on your CV and make yourself more marketable, which at the end of the day, we all want to be more marketable and learn new skills. All right, so let's get started with the data warehouse. So you see my graphic on the bottom, might not be simple to see, but any business intelligence application starts with the warehouse. So if you're going to build a reporting application, you're going to build a .NET application that does drill downs, you're going to build sophisticated charts and dashboards, what you're going to do is you're going to need to have a high performance mechanism. Let me ask a question. I promise I won't ask too many more questions. So that's why hopefully everyone will raise their hand, yes or no. So this question is, how many people in the room, well, I'll ask an easy one. I'm going to ask two questions. I lied. How many people have some kind of reports in their application today? Everybody. Actually, that's 100%. That's more than I asked when I said how many people, please raise your hand. Okay, so everyone has reports in their application. So since everyone said yes, how many people are reporting off their transactional database? Their relational transactional database. Okay, I'd say 75% of the room. Okay, in my opinion, that's a no-no. And it's a no-no because you can get tremendously faster performance by building a data warehouse and reporting off of that. And that's what we're going to take a look at today. And you're going to probably want to go home and tell your boss, hey, we need to actually build a data warehouse just for our reporting. And if you build a data warehouse properly, you can then build an OLAP cube simple when you need to. You may not want to build your OLAP cubes today, but you sure do want to build your reports today. So your reports will be far simpler because the data warehouse is denormalized to some extent. The data warehouse contains pre-aggregated data. So your reports and the queries that go against your reports will not be that sophisticated. They'll be going against data that is already crunched. I don't know if you know as much about database theory as the next person, but a system that is built for transaction is optimized to do what? Anybody? I'll give you a free Telerik t-shirt. It's data entry and updates. But think about it. Transactional systems are optimized to make us money. Right? Without the transactional system, our salaries can't get paid as programmers. So just as this gentleman said, is the system is optimized to look at one single record at a time. Either insert a record, edit a record, or look at a record, or delete a record. Okay? Reports do what? We summarize data in reports. So your transactional, highly relational OLTP system, in my opinion, is incompatible with reporting. Does anyone have the problem when the reports run, the system slows down? Yeah, because you're holding a SQL Server table lock. If you have SQL Server, or Oracle as well, you're holding a table lock most likely on that particular table. So my strategy, and the strategy that I would like, it's a design pattern. It's a pretty old design pattern, but it doesn't even have a name, is to actually build a database that contains summary and aggregate data and information from your transactional system. Now, that's pretty simple in theory, right? What's the big problem? Latency of the data. So getting data from one system to the other in a timely fashion. How many people need real-time reports? Oh, I don't believe you. How many people have bosses that say they need real-time reports, but you really know they don't? Yeah, more people. Only 20% of the room. I'm going to tell you a quick story, and then we'll get started. The quick story goes like this, do you think your business or your customer's business and your business needs to have data, the latency? Do you think that like a financial transaction like a credit card, like American Express or Visa, like their online banking, do you think that those systems should have real-time updates of the data? Yes, right? So meaning if I go right now on the internet and I purchase something on the internet and then I go into American Express, how long should it take for that transaction to show up when I go onto my online? Someone said immediately. Less than a minute. A second. Okay, try 24 hours. Okay? If I buy something right now on Amazon.com with my American Express card, it will take 24 hours for that transaction to show up on the online banking section for my American Express. You don't believe me? Let's try it. Not now, because I don't have the internet in this room, but I'll go buy something and I'll show you later. So you can use that for your boss. You can say, well, American Express waits 24 hours. Visa, same thing. My bank, I took out 4,000 rupees yesterday, still hasn't showed up. I thought they forgot about it. Right? That would be nice. I have 4,000 free rupees in my wallet. So what I'm trying to say is there is a trade-off. You can go back to your boss and say, sure, I can give you real time, but it's going to cost you a lot more money. It's going to cost you more hardware, and it's going to cost you more programming hours and more maintenance. Or I can give you closer to real time, which will still be more money, and it will just cost you probably more hardware. Or I can give it to you, maybe every hour, or 2 hours, or 4 hours, or 24 hours, whatever you think is appropriate for your business. But you can make that recommendation based upon your business. And to always let the boss kind of win, sometimes I'll provide an update now button, which they almost never click. So, because sometimes you will need to update the database, right, if you're looking for a specific transaction in a report. I understand that. There are business needs. So, just to review, what we're going to now look at is the process of building this data warehouse, and we're going to build a system that takes our transactional, highly relational database, and we're going to build a summary database that kind of summarizes all the data. We're going to base all our reports off this. It's going to be a data warehouse. So we're going to look at building that out of the Northwind sample database, because Northwind is simple. And then what we're going to do, we're going to look at the second most important thing, which is the transformation process. If you look at my graphic on the bottom, the first thing is OLTP. That represents your transactional system. And then the arrow stands for ETL, which is the extraction, transformation, and load. So we'll take a look at what that would look like. And then we have the data warehouse. And then you start running all your reports against the data warehouse. What's great is the data warehouse database can even be on a different machine. Okay, you can actually put it on a separate piece of hardware and then optimize the queries and the indices or the indexes for reporting, not for data entry. Okay, right? Your OLTP system will be optimized for data entry, and your reporting database will be optimized for reportings and cubes. And what's nice about this is when you're at the point when you want to build cubes, I said we're not going to talk about cubes today, but when we want to build a cube, then you basically already have your data warehouse built. You just point the cube wizard in Visual Studio to the data warehouse, and you're ready to go. And if we have some time at the very end, I'll even show you pretty much how easy that is. So So quick terminology when you have a data warehouse. When you have a main table that contains a lot of data, that is called a fact table. These are just good terms to know. You don't have to memorize them. I gave Saltmarch the slides, so you can, I don't know how they get them to you, but you can download them. But you don't need to memorize these right now. There's also something called a measure, and a measure is something inside of your fact table. So your fact table represents something in real life, like an order. Or in theory, it could be a customer, depending what type of system you're building. But I'll just use an order since we all know, we understand the customer order details kind of design pattern in a database model. So an order is an example of a fact table, and we would then have a report based off that fact table. So your reports are usually built off of a fact table. The data that's inside of the reports that's summarized are usually called measures. Okay? And then we also have supporting tables called dimension tables. And dimension tables, as I said, are things that support the facts. So for an order, it's usually something like the order date or a product. The interesting thing, and I think the cool thing, is that these usually come as a form of a hierarchy. So, an order date also has a lot of other data about it, like the year, the quarter, the month, and all of that. Users usually like to query by these things, but we store it as a date, which means real time in our queries, how many people do a lot of date manipulation in their query? Okay. Let me ask the question again. Not filtering the dates, but doing like a date part to get the month and then filtering on the month. How many people do something like that? Okay, 80, 90% of the room. With the data warehouse, we have that done in advance. And then you can just expose that to the user. They can click on it, and it's a very, very simple query. And you don't have to perform that difficult conversion. So let's take a look at some of the, a little more schema and theory, and then we'll just basically go right into the rest of the session. We're going to do just code. Unfortunately, it's mostly SQL code. It's not a tremendous amount of .NET code today. So hopefully you can follow along. Everyone know at least a little bit of T-SQL? Select star, insert into. Okay, just about everybody. So it's not hard T-SQL code, but it is mostly T-SQL today, not C#. Okay, so what are the types of schemas and what are the types of design that we would build for our data warehouse? Because if you build a data warehouse according to a specific design pattern, not only will you get these very easy reporting mechanisms, but when it's time to build the cubes later, okay, I'm not talking about building cubes today, but when it's time to build the cubes later, what will happen is you will have the ability to really take advantage of a lot of the wizards that are built right into Visual Studio. And you could build the cubes literally in 10 or 15 minutes. And what's great is what I like to do is if you do all the hard work now, building the data warehouse, because that's the hardest part, even though I'm going to make it easy for you, you can tell the boss. Anyone here, their boss is in the room, sitting next to them? Because I'm sorry. Can you guys, the three of you, can you all leave? Just kidding. Just kidding. You guys can plug your ears, though. What you should do is tell the boss, oh, I need all this BI training. It's really, really hard, the cube. And you can, get all this training. And then you just click and run the wizard because you've done the hard work, right? The hard work is building your star and your Snowflake schema. So this takes a lot of thought, but the nice thing about it is there's 20 years of knowledge on the internet, right? You can Google star schemas, Snowflake schemas, and there's tons of tutorials, tons of knowledge. So what are they? So the star schema takes fact tables, okay? And they take dimension tables, and the dimension tables will be in a hierarchy, and the fact table will actually be in third normal form, okay? So typical to a relational system in that respect, right? So your fact table will only contain primary keys and summarized data, right? So a fact table will look like 3 or 4 foreign keys. Does everyone know what I mean when I say foreign key? Yes, almost everybody, right? A foreign key is like a lookup column, like customer ID, order ID. So a star schema will contain mostly foreign keys and then measures, right? And your measures will be your aggregated data, like, total sales, things like that. It will contain as lookups the actual hierarchy data, right? So you'll have an order table, and your order table will have its hierarchy. Or you might have category and then product, right? That's another type of hierarchy. I'm sure a lot of you have products that have a higher hierarchy, right? That might have category. I have it super category, category, subcategory, product, subproduct. I see a lot of people smiling. Like, I don't understand. We've standardized on so many things in the world. Why can't business get together and just call products the same thing? It would make our jobs a heck of a lot easier, right? In my opinion, the star schema is the way to go. I'm going to show you a graphic that kind of compares and contrasts them. And the Microsoft technology, I'm assuming since this is .NET Day that most of you or all of you are involved with .NET. The Microsoft technology makes working with star schemas very easy, both in data warehousing and with .NET when you're connecting to .NET, but also SQL Server reporting services, which I assume you would probably use to build your reports, even though my company makes a competing product, but we don't need to go there. If you're using those reporting packages in the .NET environment, your queries become easier when you're using the star schema. Okay? The Snowflake is similar to the star, except your lookup tables, your dimensions, are normalized. And in my opinion, that makes you do too many joins in your SQL query, which makes, who would rather write a simple, I'd rather write a simple query than a query with 3 or 4 joins, okay? That's why I like the star schema better. I will show you a quick example, a graphic first, and then we'll start going in there. This is what a star schema looks like. The reason why we call it a star schema should be obvious, right? We have it actually looks like a star. And what happens in the middle is the fact table. In this particular case, I have a couple things called month, item, ship to, channel. It's pretty much an order, okay? I just ripped this off the internet somewhere. I just typed in star schema image in Google, and this is like the first one that popped up. So in this particular case, we have 4 dimensions that support the star schema. You probably can't see it in the back, but the bolded things, or the bolded columns, the 4 bolded columns, represent the foreign key. So each one of those bolded columns is actually a foreign key that is represented by the dimension table. So in this case, we have a time dimension. Okay, we have a hierarchy, right? We have quarter, month, year, all that fun stuff. We have a product dimension with, category, supercategory, subcategory. We have a customer dimension. And then we have a channel dimension, right, for channel sales and like that. And then we have those 4 foreign keys that make up the primary key. And then you'll notice we have just one measure in this table, and it's called units, which means how many units were sold. And then you could base a variety of different reports of this particular star schema itself. Okay? You could also build a cube off this. Okay? I keep bringing up the cube, even though we're not going to talk much about cubes at all, but I bring that up because it's that easy, right? You just point the wizard to, if you build your data warehouse, your reporting database with this schema, you could point the cube to it, no problem. Let's take a look real briefly at the Snowflake schema. And the Snowflake schema looks similar to the star because it is star schema, except you'll notice that we have the 4 dimensions, okay, meaning in the middle is still the fact table for sales. Off of sales, we have 4 dimensions. If you can see the colors, I know in the back this is a little difficult to see, but the 4 orange ones, okay, I'll point to them right here, right? So this is our fact table. These are our dimension tables. And the reason why this is Snowflake is the hierarchy, right? Remember we had the hierarchies are now normalized, okay? So we have supporting normalization tables. In my opinion, like DBAs like to build this, like strict, SQL geek. How many people here is like a SQL geek? Like only like 1 or 2 people admit it. I know it's not popular to be a SQL geek. I usually when I go to the discos and the nightclubs and I talk to beautiful women, I say, "Hello, I'm a SQL geek," and usually they throw a drink in my face. So it usually doesn't work well for me. It's explains a lot about me though. So that's good. No one here is a SQL geek, so we could probably work mostly with the star schema with no controversy. So let's actually take a look at what will go on like that. Let me get back over here. And this is just a quick little graphic I put in for your reference to kind of compare the star and the snowflake. But I went over all of this already. So let's actually talk about the application development itself. So I kind of covered all this already, where I said the types of BI apps that you as a .NET developer can build. Obviously, reporting and charting is pretty key. There is a new feature in SQL Server 2008 R2, which will ship next month in May. It is an update to SQL Server 2008. There's a new feature called PowerPivot, which is actually an end-user feature. And I'm doing a session later today, I think at 2:20, on what's new in SQL Server 2008 R2. And I promise you, I'm only going to show a little bit of T-SQL. I'm going to show more fun stuff later, stuff that I think developers will really enjoy. I spend more time in Visual Studio than I do in SQL Server land. But I'm also going to show PowerPivot, which is a brand new product. And I think in one of the keynotes, they're going to show PowerPivot as well. But PowerPivot is a way in Excel that you can build, your users can build tremendously powerful decision support systems on their own. But they need something to connect to. And they're going to connect to your data warehouse that you build for them. I also think on a website, is anyone here building a website that's kind of like, really big, like has hundreds and hundreds of concurrent users per minute? Okay, a bunch of you, yeah. So what I have done is use this design pattern for the website. Amazon.com uses this design pattern as well. Okay, right? So when you go to Amazon, everyone familiar with Amazon.com? Are they here in India? Oh, great. Sometimes I'm in countries where Amazon, they look at me like I have three heads. What's Amazon? Like, why are you talking about the jungle? Like, no, Amazon, the big web company. So if you go buy a book or a DVD, or you look for a book or a DVD, you're looking at you're looking at kind of a star schema. When you actually go to buy that book, you're talking to the transactional system. And they keep those in sync. Now, here's more ammunition for your boss when you tell them you want to do this, and you want more latency than they do, right? They want no latency. And we want a little bit of latency to make our lives easier. Sometimes I have purchased a book that Amazon has told me was in stock. And I get an email like 5 minutes later that says, oh no, I'm sorry, but that book is not in stock. And the reason was because they're using this design pattern and there's latency between their inventory warehouse. When I say warehouse, I don't mean the real warehouse like in the real world, I mean their data warehouse, right? So their inventory star schema and their transactional system. It's very rare that that happens, but it actually does happen. And it's just a design decision that we have to encounter in the business world. And lastly is applications we can build in .NET, or what I call light data visualization. So building drill downs, right? So we have the hierarchies. So in a .NET application with a combination of repeater controls or grid views or any type of third-party controls that support hierarchies, tree controls is another example. You can actually connect it to your warehouse instead of connecting to your transactional system. So whenever you're giving your users a view of the data, that's probably what you would like to do. Okay, so enough talking. Let's go on into my, I have a virtual PC, and kind of get started. So I have the Northwind database over here, and we don't really need to think too much about Northwind. But Northwind is, everyone here familiar with Northwind? Perfect, almost everybody. Northwind is a sample database that it first came with Microsoft Access, and then it started to come with all the other databases as well. Now it's with SQL Server. And it's just customers, orders, order details. I mean, those are the main things. They have products, right? So the order will have a product. Actually, the order details will have a product. And the products have categories and things like that. So what we're going to do is we're going to try to take a look. We're going to take a look at that. So the first thing I want to do is build an actual schema, that's a star schema, for the Northwind database. So here's how my design pattern is going to work. I'm actually going to talk you through exactly what I'm going to do for the next 20 minutes or so, because that's how much time we have left. So no more slides. Just we'll be here for the rest of the time. So what I'm going to do is I'm going to take Northwind, which is your transactional database. It's relational, and I'm going to create another schema. Right? We have DBO dot. I'm going to create a different schema called DHW, like DWH for data warehouse, and I'm going to create 4 tables. I'm going to create 1 fact table and 3 dimension tables. I'm going to create an order fact table, and then 1 for time, 1 for, I forget what the other ones are for, maybe customer, and 1 for products. We're going to create it inside of Northwind. Okay? So let's just say you convince your boss that it's time for us to build some kind of data warehousing. but the boss says start small. We don't have a lot of money. Who hears that a lot? No one? 2 people? I think the rest are lying. Oh, there's a guy. I appreciate the honesty, everyone. I don't appreciate all of you who lied to me, who didn't raise your hand. I appreciate the ones who rose your hand. Thank you. So usually the boss will say to us, oh, I don't know, it's risky, or you don't know a lot about data warehousing. Just 50 minutes with Steve at the Great India Developer Conference doesn't make you an expert. I beg to differ. I give you all permission to put it on your CV. So what we're going to do is we're going to start small. We're going to build our data warehouse just as a set of 4 tables inside of the transactional system. And to segregate it, I'm going to give it a different schema other than DBO. Okay, that's all. And you can build your reports now off these tables if you wanted to. But then we're going to pretend our business is growing and our boss likes the performance of our new, or he or she likes how fast we make new reports for them. Because that's the key thing about the data warehousing. Every time they come to you and say, oh, I like this report, but. Who hates those words? Who hates the word but? Yeah, exactly, because we hear it all the time. Or how about this one, OBTW? Anyone get that one? Oh, by the way, I forgot to tell you, we need 14 different views of this report. The nice thing about it, when you have these tables built, you can return reports around quickly. So we're going to now pretend that you've now been cranking out reports. Boom, boom, boom. Like you're a report machine, okay? Because you don't have to write sophisticated SQL statements. You just have to design the report. So then we're going to move, or we're going to create a separate actual database for the data warehouse. I only have one laptop, so we're going to pretend it's on a different computer, but in reality it will be on the same computer. So then I'm going to build the exact same schema that we built for our data warehouse inside of Northwind into a new data warehouse. And then what we'll do is we'll keep them in sync. And I'll show you how we do that. We'll actually have a little bit of SQL to keep them in sync. Every time there's an update in your SQL server, we'll push it through to the data warehouse. So that's what we'll take a look at. So we're going to look mostly at some SQL statements. They're not that hard, but you also don't need to memorize them because I want you to understand the concept of what we're doing, not the exact SQL statement I'm writing. So even if you're not an expert in T-SQL, just understand what we're doing. And that's what's more important than the actual T-SQL itself. And then we'll build a SSIS package that will actually transfer data, and that will run. And then we'll wrap it up by looking at, we'll look very briefly at how you would actually go about building a cube at the very end. Okay, so let's get started. The first thing is we're going to use Northwind, and I'm going to create a new schema called DWH. And all this schema does, there already is a schema in there called DWH. Let me just make sure I've deleted everything. Okay. Sometimes I don't want to make sure I've built all this stuff here. Ready? So let's just create our schema. And this schema will exist. Well, it's already there, so that's okay. So what I'm going to do is I'm going to create, in my star schema, I'm going to create some supporting tables. And the supporting table I'm going to create, the first one is going to be called time, or dim time, because this is a dimension. If you remember from our terminology, we had facts and dimensions were tables, right? The fact table was in the middle, and the dimensions were the lookup tables, right, which created the star for you. So I'm going to create my first one here, and it's just going to be called dim time. And you'll see we have something called a time key. And this is the only important piece of code I want you to look at for this particular table. It's just an identity. And what we're doing is we're just making a hierarchy. We have the order date, we have the year, the quarter, and the month. Now, you could argue, this violates something of normal form. That's fine. But it doesn't matter because we're building a data warehouse. So meaning is you want to provide a filter for quarter and year, you just filter this table. You don't have to write any sophisticated date parts or any crazy things like that. So I'm going to just create this table. And then what we'll do is we'll fill this table. Okay, oops, my mouse is acting up. And now I have breakpoints. That's great. I didn't even know I can make a breakpoint here. So let's just create my table. And I already have the table in the database. That's not good. Let me start over here. I know what I can do. I will do my if exists. There we go. Perfect. Okay, so, oh, goodness gracious, great balls of fire, they say. Let's try this one more time to clean up my Northwind. It's not the cleanup that I want to do. All right. Let's go this way. Let's insert into that particular database. I already have this table built, so you can pretend that I built it from scratch, but that's perfectly fine. I'm going to insert the time into that table, the order date, the year, the quarter, and the month. And how do I do that? Is I'm getting it from my orders. So I'm just getting the summary data from where we actually have it already. Let me just make sure that I've already filled this table already. Select star from dim time. And we'll just run this real quick. IntelliSense is working against me. Invalid object name because I have to put the schema in front of it. Data warehouse.dimtime. And you'll see I already have these 4 tables in the database. So we won't need to actually go in and fill them. So I'll just walk you through the code of actually what I did to fill them. But let's just take a look at what this table looks like. And we run that. I apologize that the font is small on the back. But we just have the time key. I'll just talk you through what all these are. We have the time key, which is just an incrementing primary key. We have the order date. And in this particular case, the order date just came right out of the database. And then we've done the date parts automatically, right? So I have the year, the quarter, and the month, okay? So the way I got that was when I actually filled this table. So the key component here for you to remember is the hierarchy is already built in, so we don't have to do any sophisticated type of date part manipulations. And that's what's important, okay? So that's what makes this an actual dimension table. So that's my time. I also have the product dimension, and the product dimension does the exact same thing. I'm building the product name, the unit price, the category ID, and the category name itself, okay? And I should actually have the product table as well. So let's just cheat and just say, let me just copy this and paste so you don't have to watch me type. And I'll say select star from my product table here. And if I run this query, we could take a peek at what all the products look like. So this is just taking the product tables that exist inside of our relational database, and we're just kind of merging together the products and the category table into one hierarchy. Okay? Don't worry about the data. I know the font is small. I thought I bumped up the font bigger, but I know you probably only see that if you're in the first maybe half a dozen rows. So the product table takes all that from the lookup tables that exist inside of Northwind to begin with. The third table is the employee dimension. This is the easiest table because we're just grabbing the employee and we're getting the employee's name, the employee's title, and the manager's name. And in this particular case, we're getting that manager from a lookup. In Northwind, the manager actually exists in the employee table. So we have to do a self-join to get that. Okay? So that self-join is actually a little sophisticated. And remember what I told you, don't worry too much about the SQL code. Don't worry about this particular join or anything like that, because your data warehouse prevents you from writing this query when you're running your report. Right? So it not only saves you time as a developer, meaning you write this query one time and you build it into your load script, but then you also get a faster report, right? Because you don't have to write queries like this. So that's what I said, we have an employee table. So those are our 3-dimension tables. Now we're going to have a fact table. Our fact table is built around the orders. And it's pretty straightforward because what we're doing is we're just going into our orders and we're going to put in the order date, the postal code, okay, the product ID, the employee ID, the shipper ID. So all of those come from our dimension tables. And then we're going to summarize the total sales. And then we put in the discount and the unit sales. And then we'll have all the facts from the order summarized per order. So if you know, most databases have a line item for every item. We're going to summarize all those into this particular table here. So I add some constraints. These are just for primary keys and all that other fun stuff. And then here's the actual insert statement for the order table itself. So let's actually just take a look and make sure the order table is already filled. If not, I'll run this script as well. And let me just go like this. Select star from fact order. And we'll run this query here, if my mouse will let me. Actually, I'll stop using the mouse and use the trackball on my machine. All right, select star from order. I run that, and we have all these records in there. Don't worry about the records themselves. As I said, we're just looking really more at the concept itself. So now what I'm going to do is, now that we've filled our Northwind database, and we've actually filled those particular items, what I'm going to do is I'm going to go use a feature of SQL Server called database diagrams and take a look at what this star schema looks like. So I'm going to just say new database diagram, and it's telling me that I don't support it, blah, blah, blah. So I guess we're not going to look at a database diagram. But if I was able to run this particular install diagram support, it's always risky when you try to install something in the middle of a session. So I just tried to install it, and it wouldn't let me. So I'm going to skip this particular quick part of the demo. All I want to do is show you that these tables look like a star, right? So I could draw it on a piece of paper or something like that, right? But we have the order dimension table, the order fact table in the middle, and then we created the employee, we created the time, and we created the product. So what's interesting is now let's take a look at what would normally be an extremely difficult query, or not an extremely difficult query, but a hard query. And instead of going against our relational system, let's run this query against our data warehouse database. So what I'm going to do is say, show me all of the orders that are in the first quarter of 1998 that have total sales greater than 5,000 US dollars. Now, you might say, oh, that's not that hard to do. I just got to do a few joins, a few aggregates. But then you have to do the date part to get the year, the date part to get the month. Then you have to figure out which month the quarter is in, or use date part to get the quarter. In this particular case let me just make the font a little bigger so you can see it in the back. And fonts and colors, and I'll just make this to 16. And that should be a little bigger for you to see. Hopefully, can you guys see that in the back a little better? Hopefully. So all I'm doing is I'm saying select star from my fact table, and I'm doing an inner join to the time table. So remember, we have our fact table has all the order information, and our time table contains the hierarchy, right? The time table contains the month, the quarter, and the year. So in this particular case, I'm just going to say where our time table has quarter as 1, and the time table, the year is 1998, preventing me from having to write that myself. Okay, so oops, I actually have the wrong what's the word I'm looking for here? The wrong name of the table. So let me just change the name of the table here real quick. Oops, it's data warehouse.time. Oops, my machine is, whenever you run into data warehouse there we go, dim time. Let me just run that fast. So now if we run this again, ever have problems with the mouse where you're like, come on, there we go. It's painful almost. It's actually causing me pain. And the data itself is not important, right? But the ease of the query is important. So let's take this to step 2. And what step 2 is giving us the ability to what step 2 is let's now take these 3 tables and build an actual data warehouse. So we've put this inside of Northwind already, but now what we're going to do is make a copy of this outside of Northwind. Meaning you've been the report cranking machine. You've convinced your boss, hey, let's take this data warehouse thing a little further. So now what you need to do is take this table, and take these 4 tables, and we're going to put them in their own database. And I'm going to just call this database Northwind Data Warehouse in this particular case, right? So I'm just going to say, create a database called Northwind Data Warehouse. And I'm just going to now create the exact same tables we created in the Northwind database itself. So I have, let me just see if my mouse will work better on the wood. Yeah, I think so. Okay, so we have the time table, the product table, we have the employee table, right, the 3-dimension tables, and then our fact table, right, and our fact table is down here. So I'm going to go in, then we just have the primary key constraints and the foreign key constraints. So I'm just going to run all of this great SQL here. It's going to create those 4 tables for us in this brand new database. And that ran successfully. Now what I'm going to do is I'm going to insert into those particular databases. So here's an interesting thing. when it comes to filling these tables, and we haven't talked strongly yet about the process of kind of filling these tables, you have to do, first you have to fill the table the first time, and then you have to kind of fill the table every time your data changes, okay? So, meaning there's two fill processes. The first process is just fill it for the very first time, and that's what we did in the last example. We're going to repeat it again here. But then we're going to take a look at what happens when we add data, into the original database itself. So I'm just going to kind of do some simple insert statements that just add data in for the very first time to these particular tables. Okay? So that all ran successfully. And so all I did was take all the data from Northwind, okay, and I've inserted it now for the very first time. What happens when somebody adds a record or deletes a record into Northwind? What happens to my data warehouse? I'm out of sync, right? So let's look at how we would keep it in sync. Okay, so now that we have our data warehouse built, we've factored it out into its own database. We even can put it on its own hardware if we so choose. Now let's take a look at what would happen if we want to do it ourselves. So what we can do is actually do that. I'm going to add some data to Northwind. I'm going to add some employees. I'm going to actually add some products. If you know anything about Northwind, it sells food. So I'm going to add some awesome super chocolate because I like chocolate. I figure that's good. I'm even going to add an order and an order detail for a new customer. So I'm totally adding all this new data to Northwind. Okay, oops, let's run this again. So now I've added all my rows to Northwind. Okay, so this is what this particular script does is simulating normal business operations, right? We're simulating that users have added data, they've deleted data, they've manipulated the data in that respect. So now let's take a look at a SQL Server analysis services, or not analysis service, but SSIS, SQL Server Integration Services, and I have a package here. And this particular package will actually go in and it will load all the data into my particular database. Okay, so I can actually run this particular package if I wanted to, which we will. And what I want to do is show you the source code that's behind this particular package. Okay, so meaning is to load from one table to the other, I actually need a SQL script. So let me show you the script that powers this particular package itself. So all I'm doing is I'm saying select from orders, okay, and I have a where clause here, and I'm just saying where it doesn't exist already in my supporting table. Okay, that's all I'm doing, right? So I'm just basically saying is, okay, so add to my dimension table, my fact table, just add where we don't have any data already. So in this particular case, I'm just saying select from my order table in Northwind where the order date doesn't exist and add it in there. Same thing for products. I'm just saying select all the products where the product ID is not in this particular warehouse table. And then the same thing for employees. Select the employee where the employee is not in my actual table itself. Okay? And then lastly, the same thing for the orders, right? Where the order date and the order ID is not in there. So very straightforward. So here's the question. How often do you need to update your data? Who said real time? Someone said every 1 second or real time. So what would I do with this script? I think I just heard someone put it as a trigger. Is that? Well, schedule is not. We have three choices. We have two choices. The first choice, if you really need real time, every time your tables that get updated, you can put an update trigger, and that update trigger can just run this script. Okay. In my opinion, that creates overhead to your SQL Server. Okay, right? Because every time you're doing an update, you're now doing two updates. But if you truly need real time, you just put this code in an update trigger. And every time your table has an insert, edit, or a delete, you run this script, and your databases are in sync. Everyone else was saying schedule, and I agree. So what I've done is I've put this into an SSIS package, and I use SQL Server Agent, and it runs every hour. Okay? And then if you need it less latency, okay, you can make it run every 20 minutes. If you need more, if you can get away with more latency, you just change the SQL Server Agent to run it every hour or every half hour or something like that. That is the magic behind it. Now that you've written the script, as you can see, it's very, very simple. All you're doing is saying, show me the data that is not in my data warehouse, and then move that data over. You write these scripts one time, and then you schedule it, and then you forget about it. unless you change your schema, of course, right? When you change your schema, that's when you're like, oh. And I won't lie to you, that's not fun, okay, right? When you change your schema around, you have to accommodate for it in your warehouse as well. So luckily, we don't really change our SQL Server schemas around all that often. We change it around mostly when we have a big business rule change or a business change that warrants the schema. So you will create a little more work for yourself, but then you can continue cranking out those reports. Now, before I complete, I have another minute or so to go only, I just want to show you how easy it is to actually build a cube. And in this particular case, I know you can't really see this, but let me run this, because I do have about 1 minute to go, or 2 minutes according to that clock, but I think I only have about a minute. And I ran this, and you can probably see in the bottom right-hand corner, I have a green checkbox to say no changes detected. Because what I have now is an actual cube. And you probably can see it looks a lot like a star schema, except I'm missing one, right? Because we only have 3 dimension tables. But what does this look like? This is our data warehouse, right? This is the schema that I tried to pull up before in the diagram view. In the middle is our order table. We have our employee, our time, and our product. Those are our dimension tables, okay? So the order table is our actual fact table itself. This is our data warehouse view. And then if I click on the cube, okay, we actually have a cube that's built on top of that particular data warehouse. It looks very similar, doesn't it, right? Because it is, right? The cube takes these particular items in, and I can actually go in and start drilling into this particular cube, which I won't do because, as I said, we're really talking more about the data warehouse in this particular case. But because we built our data warehouse using the star schema and used it for our reporting database, and then because we filtered it out and we built our actual data warehouse in a separate database, now when I run the wizard against that data warehouse, I actually have a cube, and I can get that cube built in just a matter of seconds. I literally built this cube in 2 or 3 minutes, okay, which I don't have because it's 10:20. It's time to wrap up the session. But literally, you could build the cubes there. So just to recap before we all go is what I'd like you all to do is go on home and use the opportunity to tell your boss you learned a lot about business intelligence, and tell them that you think we should start segregating our transactional data from our reporting data. So I'm out of time. So what I'll do is I'll go to the back. If you have any questions, there's actually a booth for my company literally right out that door. I'll just stand there for the next 10 or 15 minutes and take your questions there. So enjoy the rest of the Great Indian Developer Conference, or the Developer Summit. I'll see you at other sessions throughout the day. If you don't come to my sessions, it was great meeting you at this one, and enjoy the rest of the show. Thank you.